Okay, we're in section 91. As always, there'll be contents, there'll be examples, and then exercises to get busy with. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF document is being made available to the Prison Mathematics Project participants only. I realize other people may be watching these videos, and if you're a student or teacher and interested in getting a copy of this, I'll let you know when it gets published. Just reach out to me and let me know you're interested. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. Let's take a look at the topics. And this says reversion of series. Really what they're doing is they're trying to find an inverse. All right, so they're trying to find the inverse of a series. All right, so I want to just, certainly we want you to read through Wells's work. I'm going to go through the way I would do it. I'm not going to say it's substantially different from what Wells does, but it may sound different. All right, so I'm going to say it says revert to 4 terms. Basically, we're trying to find the inverse with 4 terms in it. All right, so what's an inverse going to be? An inverse of this thing is actually easy to write down. The inverse would be x equals. And what I don't know is, I don't know the coefficients of it, so I just put down, it's going to be a y plus b y squared plus c y cubed plus d y 4, yada, yada, yada. All right? So I'm looking at that and I'm wondering, can I do that? And someone says, how could you do that? Well, I'm going to use this. I'm going to plug it in here. And that's what we're going to do, start with that step. All right, let me point this out to you. First step, assume it can be done. All right, second step, make a substitution. So you can take this, which is y, and plug it in over here. Yeah, it's a lot of work, I know that. So what are you going to get? X, wherever you see a y, you're going to put down what it is. It's 2x, it's a long thing over here. All right, then b times that thing, quantity squared, c times that thing cubed, d times that thing, quantities, and so forth and so on. I think you get the idea. Here comes the problem. Right, yeah, what are the problems? It's multiplying the thing out. It's not easy. I mean, I don't find it easy. I find it very tedious, but you can multiply it out. So when you do that, what you start to realize is basically equating coefficients. All right, so I'm going to claim that you don't want to go out too far, but you certainly want to go out to the level where they want 4 terms in it. So you're going to have to go out the expansions at least to the 4th power. All right? So I'm going to say every single expansion should be taken out at least to the 4th power. All right? So I want to point out I did it over here. This one over here, I kind of a little wild with it, up to the 5th power. This one over here, up to the 6th power. I guess I figured I could do that. This one over here, I just took it out 2 places, but at least to the 4th power. This one over here, it's going to have no 4th power in it. All right? Yada, yada, yada. Hope you realize after I get to E, F would have degrees much higher than 4 in it. All right? And then what do? I want to point out what I do. I equate. All right? So the first thing I'm going to equate is I'm going to look at the terms with x in it and only x in it. And I only see one term. And it's going to be this term over here. That's the only term that would have an x in it. If you look at every other term there, it'd have more than an x in it. So I'm going to say what you have 2ax. What does that equate to? X. Everything else on the left-hand side is going to be 0 after that. Everything else. But what I have to do, I have to fish around now. All right? So I'm going to fish around for squares. And do I see them? I do. And I want to point out I'm seeing here. And where else do I see a square? Here. And that's about it. So what do I see? Let's see what I see. I see minus 3a's. And I see 4b's. All right? Now, if you know what A is, you can clearly find out what B is. Let me put out what I mean by that. That would be 0, 4b. And what's the A? A we determined as a half, right? So the A is a half, and that's going to be minus 3 halves, right? And again, we're equating the x squared with the x squared. We're just looking at the coefficients. So 4b would have to equal 3 halves, or b would equal 3/8. All right, that's how we're getting that one over there. all right? And then you do the cubes next. And looking at the cubes, I mean, this is a cube over here. Whoops, sorry about that. I didn't mean to do that. That's a cube there. There's a cube here, and there's a cube over here, all right? So I'm just looking at cubes. So what I see, well, I see 4a, I see minus 12b, and I see 8c of them, all right? How do you get to c? Again, it's going to be equating the coefficients. But let's go through that. I'm going to erase this business over here. Get my pen out. Go back to black ink. So I get 0. Whoops, let's go back to black ink. 0 equals 4 times a. Well, 4 times a is easy, just 2. Then you get minus 12 times b. That's a little more complicated, right? 12 times b. b is 3/8, right? So I'm going to say 4 goes to this 3 times 2. So 9/2. And then 8c. I don't know what c is, by the way. Well, let's do this. That's going to be minus 1/2 plus 8c. Mistakes happen, that's why we give you a k. What do you get? 8c equals 1/2, or c equals, I think I made a mistake somewhere. I got to check myself now. 4 times a is 2. This looks good. 12 times b, maybe that's where I made a mistake. B was 3a, so 12 times b. I said 4, right? 2, 3, 9/2. Yeah, I got that. And then 8c. Oh, I see it now. All right. It's really stupid arithmetic mistakes. But again, I'm glad I have a key there to look at that. I'm going to erase this over here. I'm glad I have a key. And part of that is just simply fessing up to my mistakes. All right, so 0. And 2 is actually 4/2, and 4 minus 9 is minus 5. I made a mistake before, but I caught it by looking at the k. And you might have caught that by listening to the video, by the way. 8c would have to equal 5/2. C would be equal to 5/16. Okay, I agree with that. Let me get my eraser out now. I'm kind of erasing my chicken scratch. And again, when I write your notes, what I do is I actually write notes up on a piece of paper, and then I type it up. All right, type it up. Some of the chicken scratch I don't type up, because otherwise the document would become, not 2,500 pages, but 25,000 pages if all my chicken scratch were down there. And no math book does that, by the way. You may be interested in looking at chicken scratch to learn, but and also to do problems. I'm not saying otherwise. I'm going to go that last guy. We've done these first 3 guys over here. And I'm going to go the last guy. And what's that one going to be? Well, let me just erase this business over here, because I really want to emphasize what we're looking at. We're just looking at this expanded model. And I'm looking around for something. What am I looking around for? I'm looking around for, let me get a nice new color here. I'm looking around for 4th degree. So I see one here. That's a little too dark, isn't it? Let me just erase that again. Go back to a simpler color. 4th degree. Wow, I'm really screwing up here. Let's get the opacity of it down. That's a 4th degree, right? 4th degree. 4th degree. 4th degree. And that's about it. Right? You could imagine how tedious it would be if they asked you to go out further. And that's where machines come into play. All right, machines can do that. You would just have a tough time with it. So what am I seeing over there? Let me just go through that with you. So minus 5a. Again, we're talking about the 4th degree term. And then it's going to be 25b. And then what are you going to get? Minus 36a. And then you're going to get 16d. All right? What is it going to get? We're going to get d. Let's write this down now. So 0, I'm just equating the coefficients. 0 equals, well, minus 5a is minus 5/2. Again, I'm looking backwards to do that. And 25b is 75/8. Whoops, I made another mistake. Is 75/8. Again, I'm looking at these things to do that. Again, minus 5 times a half minus 5 halves. And then 25b is going to be 75/8. Now, I got to do minus 36c's, right? I'm going to write that on the side for you. It's more difficult. There's no doubt about it. Let's see, minus 36. And what's C? 5/16, right? Well, I'm going to divide by 4. That would give me 4. That would give me 9. So I'm going to say minus 45/4. And then I get 16 D's. I have no idea what the D is, though, right? So I'm going to get my eraser out. This is my chicken scratch on the side. Got to cut common denominator. Let's hope I don't make the same mistake twice. But that's what's nice about an answer key. I can look at it. If I have an answer key and trust the answer key, and I hope you can. But again, if you can't, you bring it to my attention. Say, I can't trust that key. It looks like it's wrong. Looks like 8. And let me just put that down for you. And then, 4 times 2 is 8. And 4 times 5 is minus 20 now. Plus 75. And then minus 90, right? All right, let's take a look at that. And you're going to get 0 equals, that's an 8 still. And you get minus 20 minus 90 is minus 110. Looks like minus 35 now. Plus 16D. So 16D would equal 35/8. I'm going to divide both by 16. You get 35. 8 times 16. 35. And 8 times 16 is 80 and 48, 128. And again, that's listed for us. So we can write it down now. We got the coefficients, right? This is a lot of work. It's tedious too. I think some of the worst parts of the work are just expanding, all right? And again, it's tough. I'm not saying otherwise. And, I don't mind people using machines, but you really should do some basic expansions on your own. But at some point, you do want to get the machine to revert these guys, all right? But we got a reversion there, all right? Let's take a look at this one over here. Let it be required to revert the series. And then it goes on, the series may be written as. Well, that's an interesting concept, what they're doing over here, saying y minus 1, and then they put the series over here. By the way, this is a famous series, but I wouldn't worry about that. All right, would not worry about that. So, what do they do? I want to point out that they see these power things over here, like, a 1, a 2, a 3, and so forth and so on, all right? So they simply just say, x equals, let me put this over here, and then it's going to be a times something. And again, I want to point out what we're doing over here. We're doing this thing over here. We got this. That's the first power. We got this, second power, third power, fourth power. All right? And then the question becomes is, what's y minus 1? All right, you just plug it in. All right? And you're going to equate the coefficients now. And, well, that's easy. I want to point out what I mean by that. Y minus 1 is just this thing over here. That's all it is. You plug it in. All right? You just plug it in. And if you did that, I would say it's really not bad to plug in, but you're going to get this. X equals A times, and what would that give you? Y minus 1 is going to be X plus x squared over 2 factorial plus x cubed over 3 factorial, yada, yada, yada. It goes on forever. Plus b, this thing, and this is the tough part. We're just writing it down and realizing you have to do that. And that's going to be what? Squared, right? And you keep going, plus c, x plus x squared over 2 factorial, x cubed over 3 factorial, yada, 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 cubed, so forth and so on, right? D would be what? Plus d, x plus x squared, 2 factorial, x cubed, 3 factorial, yada, 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 to the 4th power. You could do e and so forth and so on. But the problem is this, though. It's the expansion. And I know in the prior problem, I tend to write a lot of stuff down there for you. And again, you might say, oh, this is all chicken scratch too. It's necessary, though. It needs to be written down. So I'm going to say if you do that, And certainly, just looking at the first guy, there's only going to be one term in all this expansion that would have an x in it, and that would be ax. This got to be really easy, all right? What would a have to be? A would have to be 1, all right? A would have to be 1 in that case. Now, if you do the x squared term, again, it's tough. I'm not saying it's easy for you, but there would be no x squareds, all right? You notice that? There's no x squareds on this side over here. So you would say 0x squared. And this is the tough part. Someone says, what do you mean the tough part? You're looking at terms with squares in them. Well, this one's easy. That's just going to be a over 2 factorial. And 2 factorial is just the number 2. All right, I'll write that down for you. All right, then you got to look at the next guy, and you're squaring that guy off there. And I hope you realize if you did square that off, you would just get bx squared in it. All right, so I'll put that down for you. Again, someone says, oh, you didn't do the multiplication. You're right. I'm kind of looking at it. If I did do the multiplication, you certainly would get an x squared in it, just in the beginning. Everything else would be higher degree. So I just simply said there's a b in it. Give me 1 second. You know what a is? A is 1, right? So what do you get? 0, 1/2, plus b. Well, b would have to be minus 1/2, right? That stands to reason. All right, these are making sense over here. Let me get my eraser out. I'm going to start to erase this business over here. That was easy. And now what do we do? Well, we just did squares. I'm going to go to what next? I'm going to do cubes. All right, and there's no cubes on the left-hand side. So I'm going to write that down. 0x cubed equals, well, from the first one, what would you get? You would just get a over 3 factorial. I'm looking at the cube now. And what's a over 3 factorial? 3 factorial is 6, right? And for the next one, which you're squaring, right? That's tough, by the way. I want to point out what I mean by that. You're getting, x plus x squared over 2 factorial plus yada, 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 times x plus x squared over 2 factorial, yada, yada, yada. I think you get the idea of what's going on over there. We're looking for a 3rd degree one. And I'm going to say for the most part, I think I'd get, let's see what we get. I can look at that. You get, well, we're just looking at we're looking at x cubes. I'm sorry. We did the x squareds already. I don't want to do that again. We're looking at the cubes, right? So what would you get over there? Well, it's going to be this guy times this guy. That would give it to me. That would give me x cubed over the 2. And then you'd get this guy over this guy, and that would be x squared over 2. So there'd just be one lousy b now, all right? Again, we're looking at this guy over here. All right, now let's look at the next guy. The next guy is really not so bad. When you cube this guy, the only way we get that is by this x times x times x. So it's going to be plus c. And again, they're x cubes. What do you write down? 0. What was a? A was just 1, so you get 1/6. What was b? It was minus 1/2. I'll write that down for you, plus c. Let's do the arithmetic. That's 6. 1 minus 3 plus c. Again, we have a key to look at. We can always check it. And what do you get over here? 0 equals minus 2/6 plus c. So c would have to be 1/3, right? Because you get 0 equals minus 1/3 plus c. Yeah, c has to be 1/3. So that makes sense. All right? So yeah, someone says, what are you going to do now? It gets tougher and tougher as they go up in power. There's no doubt about it. Let me just erase this business over here. I think this was satisfactorily done. And on the left side, there's no 4th degree terms, right? So what I'm going to do is, I'll say there's none. So 0x4. And this is always a tough part for me, so I'm looking at it. And I'm wondering what terms would give me x4. And let's just look at the first guy. It's a square problem, right? And we're looking at x4. Well, that's not so bad. It's just simply x4. This is the a, by the way, a. And x4 would be what? That would be over 4 factorial, which we know to be 24. Let's go to the next term. And that's the b part. I know there's a b over here. I just don't know what's coefficient. But it's x4. So I'm going to say, I have to write this down, by the way. And it's always difficult. I mean, I can't say it's going to be easy to do. Some people are really good at it, though. But it's going to be, let's see, I'm seeing x times x cubed over 3. So that would be x4 over 3 factorial, and that's 6. And I'd see another one of those too. That's going to be another 6th. And then I see this x squared times over 2 factorial times 2 is a quarter, right? That's coming out of 12, isn't it? And you get 2 plus 2 plus 3. That's 7/12. All right? Let me get my eraser out. I think I did okay with that. And now we're going to go to that, the next one, right? Oh, boy, that's a tough one, too. And that's going to be that, we're looking for force, right? I got to be careful here. And I'll point out what I mean by that. This thing is written down like this. Let me write this down for you. X plus x over 2 plus x, let's see, 3 over 3 factorial, which is 6. The next one would be what? X 4 over 24. And this goes on forever. It's crazy looking. But there's actually 3 of them. All right? I'm sorry, 4 of them. Did I say that right? Yeah, we're doing 4. We're doing this, the 4th power of this. I'm sorry, I misspoke again. I lost track of what I was doing. Let me just make sure I was doing something over here. Oh, we're looking, it is the 4th power, but we're looking just for a cube. All right, so that would be written down 4 separate times. Wow. I'm sorry, yeah, 4 times. Am I doing that right? I can't remember if I just did the C. Yeah, I did the C, I'm on the D, so it is 4 times, I'm sorry. So I think I did, yeah, I got this one. I'm sorry about that, I lost track what I was doing. We're doing this one. We're doing the D. And the only way I get a 4th out of that is this one right over here. Oh, you know what? I didn't do the 3c over 2 yet, did I? Oh, I see what I didn't do. I didn't do this. That's what I forgot about. Let me erase this over here. And I got the 7b over 12. I just lost track of what I was doing. And where would I get the 4th degree from that? Well, let me write this down for you. It'd be this one times this one. Well, it's down 3 times though, isn't it? Let's write it down 3 times. And these are being multiplied, by the way. And you can imagine how tough this gets when things go on, especially if you get distracted. You start saying, did I do that one? Did I do this one? And we're looking for the 4th power on that. Let's see, not x times x times x. That wouldn't work out. I'm sorry, I think I made another mistake here. I didn't put the x squared down. And let's see where you get the 4th in that one. You get x. Let's see, you get combinations of 3, right? So this, and that would do it. And you could do that in how many different ways? Well, let me write that one down. That would give you 1/2. And let me do another way. Let's use in this term over that. That's exhausted. Now, if I did this one over here, what would it be? It would be this one times this one times this one. And that would be it. So another half. So what's going to be 1/2 plus 1/2 is a D. That worked out pretty nicely. So this over here, let me get my eraser out now. It's tough though. I mean, I get lost too, and I have to go backwards, and Let me erase this over here. I think I got distracted with that. I can't remember if I did it all. I think I did the 3c over 2. I just can't remember now. So let's put the next thing. Whoops, sorry about that. Let's write this down. So what do you get? We're doing that last one, right? Which is A. That's 1/24. The B is a half, right? So it's going to be minus 7/24. Again, I'm doing these things over here. The C is a third, so this will be a half, plus D, and that better be equal to 0. So 24 is a common denominator. 1 minus 7, and that's going to be plus 12, plus D, equals 0. Let's see, that's going to be 6/24 plus D equals 0. 1/4 plus D equals 0. D equals minus 1/4. All right? So everything is done. All right, everything is done. And what do? You just put the coefficients in, and you get it. Let me erase this over here. And again, I know it's a lot of work. I find it to be very tedious, and I get easily distracted, and I lose track of what I'm doing over here. All right? So let me point out, during Wells' time, they didn't have machines to do these reversions, but I would say try to practice it, all right? And part of that just keeping some good bookkeeping skills over here. But, you know, I write down the steps for you, and I go through the equating the coefficients for you in these problems over here. All right, get the reversion. All right, same thing for this one over here. I'll write the steps down for you. I'll do the substitutions. I don't do all the work for you, but you'll get those coefficients over there. All right, you get those numbers. If you feel there's an error in any of these things, please bring it to my attention. I think that for the most part, they're pretty straightforward. Although tedious, I will say that, tedious, they really are very, very tedious. All right, and there's quite a few problems. All right, 8 problems. All right, you eventually get to the Sage business over here. You know, just to briefly go through it, this one over here, and I'm actually just using a computer to do a reversion on it, all right? You may want to take a look at that, okay? By the way, some people are often confused by what Sage does here. Sage appears to write things backwards, like they start with the high degree and go to the small one, where we're kind of write the small one and go to the higher one, all right? Ascending, descending order. Okay, so the deal about this over here, it's not really to go over Sage, it's to get you guys to do those problem sets, all right? So my name is Bannon, that's B as in boy, the @ symbol, NNON.US. And my recommendation for you is this, work the problems. Could I have made a mistake? As you plainly say, I get distracted, all right? I start talking, I forget what I've done, and I might actually do the wrong thing, right? If you feel that I've done a problem incorrectly, right? Now, certainly when I'm doing a problem, I'm not yammering through it. I actually have a pretty quiet piece of paper, and I work on the problems and I get an answer, all right? I'm pretty sure my answers are good, though. But again, you may want to say, oh, Joe, I don't believe that's a good answer. I got a different answer, and I did this, and that. Let me know. What would you do? You would say, hey, I'm doing exercise 91.3. Don't tell me the page number. The reason for that, page numbers may change. So you're in exercise 91.3. I'm working problem number 4, and I believe you made an error. I believe the correct answer is this, and this is where your error is. And I'll correct it, and I'll give you credit for it. Again, I really appreciate you paying attention to this, and I appreciate those students and teachers that reach out to me reporting errors. Thank you.